We're live. I'm early by a couple of minutes. It's not even 7 o'clock yet. Hopefully you guys are doing well. It is Sunday night. Maybe you guys are watching, I don't know, Sunday Night Football or drag racing or whatever's on. That's all good stuff. Tonight we're going to talk about, I have the photo. The thumbnail photo is one of the versions of the Super Richie intake manifold that I did. And as you can see, I basically threw the kitchen sink at this one for a couple of reasons. One, I wanted to test a lot of different variations because I wanted to see what was going on. And also because it was a Honda. For those of you who don't understand Honda, the thing that I love about this is my favorite part of this is the dolly that I'm using to hold up the intake manifold with tape and baling wire, as I do. But the reason for that is because Honda is really good at what they do. I mean, that B16 was already making 100 horsepower per liter from the factory, so it's pretty strong. And then they had stuff that made more than that. They had the 1.6 liter Civic Type R motor, the B16B, and then the Integra Type R motor that made 195 out of 1.5. I mean, not out of 1.5, they wish, out of 1.8. So they were really good at making high specific outputs. Their K series were making good power, and obviously the F series, F2000, or S2000, that kind of the F series S2000 that had the highest specific output for a long time, until I think Ferrari eventually beat them. But that's an impressive amount of power. And so, needless to say, when they designed these things, the cylinder heads and camshafts and intake manifolds, they were looking at a lot of different things. I mean, 100 horsepower per liter is a lot. And so they did their homework. It's not maximized by any stretch of the imagination. Obviously, their engineers are really good and could make more power. But my job was to try to find an intake manifold that worked better on, I think this motor had some sort of cams in it that would work better on there and help me make more power. Because I certainly thought that there was power in the induction system, having tested the P30 B16 intake manifold versus the Type R manifold, which was kind of an upgrade. The P30 was better everywhere until the very top. Again, short runner, a little bit bigger plenum and stuff. But the Type R made a little bit, and it was designed obviously for the bigger 1.8 liter motor, and it made power at a little higher engine speed. And we see that when we test other longer runner factory intake manifolds. So what I wanted to do on this particular run was test a number of things. One, right off the bat, it had bigger throttle bodies. It also allowed me to run inlet tubes, because we know that on the factory B16, the power curve, you could definitely adjust the power curve with the length of the inlet pipe in front of the throttle body. That's Helmholtz resonance. And it works very well for some reason on a 4-cylinder. It seems to be much more receptive to it than when I've tested this many times on LS motors. Putting an inlet tube in front of the throttle body didn't really seem to change the power dramatically the last 3 or 4 times that I've tested it. I want to keep testing it because I want there to be something. But in the times I've tested it, and in one instance, I went through 3-inch pipe, 3.5-inch, 4-inch pipe, different lengths and bends, and just all kinds of stuff. And it just seemed like a big giant waste of time. But on this, so we wanted to have inlet tubes. We want to have a radius entry on the length of the tube, because the length of the tube makes a difference, and then a radius entry on that. Good size throttle bodies, so we don't restrict flow, because maybe we could pick up a little power there. The plenum size was bigger than the factory because we had 2 of them, and they were bigger anyway. As you can see on the back side of this, the side facing you on the photo, there are 2 throttle bodies on that side also. We could open the whole thing up and open throttle bodies up. But the reason that I put those on there is so that I could open them up and join the 2 plenums, and you can see the looped Y-pipe, basically connection tube between the 2, so we could run them individually as 2 sets of 2-cylinder engines. Because the other thing I didn't tell you about yet, or we could combine them. And I thought, oh, well, we're going to adjust this, and at some RPM, like I've seen before, it's going to magically cross over, and it's going to be like an intake VTEC setup. You know, the GSR has a different runner length. This isn't that, but this is a different plenum volume. So I was hoping that we could pick up a little bit of power from that, or at least see some kind of change. Then also you'll notice that the runner lengths are adjustable. What they are is slip fit tubes. In this case, they're 2-inch aluminum tubes. And the end section that's connected to the cylinder head is a stock P30 flange that we ported And then what we've done is just basically crimp down the tubing and welded the tubing in place. And then when it goes out to a round tube, and then we can go the lengths of the round tube, and we could put little sections in and make it longer and shorter as we deem necessary. And as the test dictates it wants when we adjust it. Because normally with intake runner length, you get some pretty good gains. You definitely get changes in power. So we could try to fine tune the intake manifold to what it wanted. The other thing that I did on this is and we were pairing it with the firing order. So I have 2 runners going to one of the plenums, and then 2 of them going to the other plenum. So we've separated the firing order on the 4-cylinder, separated in the plenum, so it's not overlapping, and one of them is not scavenging from the other and robbing some of its precious cargo, its wave or its airflow. So I tried to, and the way that this is set up is because there was enough slop in the intake in the runners, I could make any combination of runner, I could put any 2 in either one of these. I could run the ones that are right next to each other, the ones that are opposite, the ones that are on the ends, and then the ones in the center. I could pair all of them. So it didn't matter. So that was kind of cool. So as you can see, there's a lot there. And when I first started designing this, I thought, oh, well, I want to do this. I want to make an adjustable runner length. We know we want to do that because I've done that on every Super Richie intake manifold. We're definitely going to do that. It needs to be big enough so it needs to flow, because that head flows pretty well. It's making pretty good power. It needs to at least match the head flow, which those tubes definitely do. And so I was hoping that maybe we could go up and flow a little bit from the tubing diameter, the inside diameter, and shape and radius entry, because there are radius entries inside each one of the plenums, and we could have a radius entry. I could improve the flow. We'll just get power from flow. I was hoping. That was my mindset at the time, and subsequently that's probably not the case. But that you don't want to restrict it, because if you don't want it to flow less than the stock intake manifold, unless you're just trying to make power at a different RPM range, and then you've done it with a bunch of runner length and it necessitated flowing less. But that's not what we were doing here. So I wanted to have maybe a little bit more runner length and then more flow, and that would be the magical combination, because we could make more low speed power from the reflected wave and more top end power, and nothing turned out like that. So essentially none of this stuff works, or at least didn't work any better than the factory intake manifold did. I had to really struggle to even match the curve of a factory P30 intake manifold. And so I was very disappointed after going through all of this and all of these different iterations of this manifold that were possible. I thought for sure separating the power pulses, separating the 2, putting 2 runners in one plenum and 2 in the other, that was definitely good. There was definitely going to be magic there. And I thought, we knew from before, like I said, changing the inlet tube length, we could make it long or make it short. We would definitely change the power there. It seemed less receptive when we were only doing it with 2 runners for whatever reason. And then I thought that the magic in the back, joining the plenum volumes with the I don't know why I did it with throttle bodies, and so we had to weld the thing together. But it was a lot of work. And sometimes, a lot like the stories I tell about doing engine masters, it's a lot of work, and it's a lot of work for not getting anything, but you get something out of it. You learn something from it. And so that sort of information is always valuable. It doesn't necessarily have to succeed. Like I found out when I was doing engine master testing, way more ways not to make it work on that particular combination, or way more ways to make a lot more peak power and lose power down low, or vice versa. But then ultimately didn't end up giving me the average gain that we were looking for, specifically for engine masters. But it still showed that, hey, there were things. I just wish I would have been really and less narrowly focused when I was doing that testing, only interested in the average number, because every time we'd run 3 successive tests to make sure that we got a good average there. And then when we would do that, you'd make sure that because we were looking for onesies and twosies numbers. We were looking for 10s and 20s, but those were hard. At the beginning, those were easy to come by, but then later on, they were very hard to come by. But when you're looking for onesies and twosies, you have to make sure that the oil temperature has to be exactly the same, the water temperature has to be exactly the same, the air temperature, all that stuff. And so it's a long, involved testing process to make sure that all that's the same. You could just keep throwing the hammer down and doing stuff, but you may or may not be getting the thing that you want, especially when you're looking for only one or two. So it took a long time to do all that, but you find a lot of stuff. But since I was so narrowly focused on what the average number was, oh, that didn't work, that didn't add any power, so we just throw that thing away. But I wish I would have been more detailed in my notes and wrote a note to myself, hey, look, when you do the 1.7 rockers on just the long runners and then run 1.6s on the exhaust on all the others, that it did this. Because there's so much testing that we did to try to find. I mean, I tested everything, even nonsensical stuff. We tested it. I got good gains from stacking gaskets of all things. So we tried a lot of stuff, and some of it worked, most of it didn't, and then some of it worked somewhere and not other places, so that we just didn't get an average gain. This particular intake manifold, I'm very, very proud of, given all of the adjustability and all the different things all the different variations that I could make from this intake manifold. It was really, really cool. This was the intake I think that I was most excited about testing, this particular Honda one. And unfortunately, it was also the least successful, and that sometimes happens. So on that note, let's see what you guys are doing. Squirrels in the house. I just got my LS put together tonight. Great. That's awesome. I'm new to the channel. I like your channel. What's your business name? Where's it located? Harold, I don't have this is what I do. This is my channel. This is us. You're talking to me. This is what I do. I do dyno testing and have done for the last 30 years or so. Lots of stuff for the magazines and then now for YouTube. But I don't have a shop. I don't build engines. I don't do any of that stuff. All I do is testing and then give you free information, basically. Maryland's in the house. The 3-foot long intake runners made me think of the old cross ram. Yeah, obnoxiously long. These weren't. I mean, that was the longest iteration, if I remember right, of the. Because I knew that on a B series, if you look at even a P30, which is longer than a Type R, it's nowhere near that long. And so I like we did with the plug gap stuff. You take big swings at stuff, and so I wanted to have a setup that had way more runner length than stock or anything that they would run, anything that you would think would be feasible, so that we could show how bad, I would miss by going that long, or how bad we would rule and have the B16 make B20 torque. Yeah, that didn't happen. How much can you advance the truck Norris cam? How much would it shift the power torque curve? Future test? Actually, it's not going to be a future test. That cam is already advanced enough, and I don't think we're going to pick up any more low-speed power. I don't think I would even go looking for more low-speed power, given what that cam already does. Should I change oil after a cam swap? I don't know. We don't do that. That's why when people see how gunky these junkyard motors are, and if we're taking the cam out and put it back in, yeah, what if you knock something down? Oh, believe me, stuff knocked down. Stuff gets knocked down while the motor's running. If you take the valve cover off and you can literally see sludge and the motor still runs, what could happen? Can't be any worse. Why didn't you make the tube inclination of this Honda in the same as the angle as the port? It's straight into the port. What is your opinion on fast EFI 4150 throttle body for a blow-through setup? I've never tried one of those in a blow-through, and as long as you can get it to cooperate every pull and do the same thing every pull, it should work. Buffalo's in the house. I have a boat motor, 540 inches, 8.1, 8-to-1 compression, twin turbo, 15 pounds, pump gas. What air fuel ratio should you be? I would think you'd be like at 11.5 or so, or less. I don't know about the timing on pump gas. Not very much. I don't know what heads you have on it, or if you know what timing the thing wants NA, but on a big block, it could be 35 or 40, depending. Have you ever done any testing with Ron's flying toilet? I have not. And on 15 pounds of boost, you're going to want to be, I don't know. I'd have to go back and look at the 540 that we did. Maybe I can look at that and see what the timing was. I can tell you what the timing was when we ran the 540 blower or power adder motor from Blueprint, because we ran that with turbos on it. But I'm sure that we would have run good gas in it, though. I know that we didn't run pump gas, but maybe I can find out what kind of timing it wanted NA, though. Dyno results: big block Chevy, stroker, big block Chevy. Come on, 540 Blueprint. 540 nitrous and blower. Let's see. NA base. Let's see. Test description. This says that it wanted 35 degrees of total timing NA. So my guess is you probably would be on pump gas. I'm thinking you're going to be around 20. Do you prefer ported or manifold for street cruising? Milo's good. He's actually not in here tonight. Honda D series budget build. Well, you just would get a used one for that. Yeah, we'll put some Arco graphite in it. I've never done a Ron's flying toilet. I think I answered that. Do you prefer ported or manifold vacuum? Are you talking about for the distributor? Like to build a D series Honda? I've done lots of those. We've done lots of turbo stuff on those. Dan's here. Richard, you should do a video breakdown on your big horsepower stock bottom end engines, going over their contents of being just the stock bottom ends. Aaron, I saw the comments on the Hemi stuff. I think I commented on that. All the big bang motors are all stock ones. That's part of the deal. I don't do anything that's not on the big bang stuff. I don't do anything that's not a stock bottom end. That's part of the deal. All I do is ring gap, and then we put usually good heads and cam and stuff in it. At least you can experiment with your intake and test it on the dyno. Yeah, but that's not free. So it's also, in addition to being not successful, it was also expensive. It's multi-port EFI. Went with a 12 air fuel, 24 degrees, Brodex, BBX. The driver's side burned all the pistons. 24 degrees seems like a lot. 12 air fuel is too lean. That's like NA stuff. You're going to want it to be way down in the 11s, down less than 1150. My 11-to-1 540 likes 37 degrees on 93 octane. If that's an NA motor, that's right in the ballpark. I'd hatch with a D15. I gave my hatch to, mine was a 94 VX, so it was a D15 Z1, and with a stock engine and stuff in it. And I drove that to get good mileage. I was going back and forth to West Tech, and I gave it to Chad so he could drive it around and get good mileage on it. It's still running really well. Although I wish I would have turbocharged it, because it would have been fun as a boosted one. How much compression can you run NA on an E85? An unlimited amount. So the compression that you could run is going to be more a function of your displacement. Can you get that compression out of it? E85 should allow you to run whatever conceivable compression you want on there. You may have to do something with the timing, because the static compression and octane, and E85 has more than just octane, it has other kinds of cooling. But that's one of the things, or two of the things, that you would look at for detonation. There's lots of other things that you'd want to look at. Air temperature and water temperature and chamber design. And there's lots of stuff to consider there. I'd love to see you design an intake for the 2.2. I am going to do that. I'm going to definitely make an adjustable intake manifold for the 2.2. That was optimized for the NA range of the cam you find is the best. You know, people so design it to be a 3D printed, then sell the files to raise money. I don't think I would do that. Because I won't. You saw what I did. I don't do 3D printed ones. I just do adjustable intake manifolds out of aluminum. Richard, something came to mind as an idea for testing the changes in power and tune required from full mufflers to a cutout. I honestly don't think you're going to see very much there in terms of what you'd need to tune is for the change in power, if there is any. The video that I did of the full exhaust versus the headers and open pipe, which would be a cutout thing, would be the same kind of thing. Although I think with a cutout, part of the exhaust, unless it completely covers the exhaust the other way, I don't know what the valve does. Unless it completely covers the exhaust, some of it's going to go out the exhaust too. But if you have a gain in power from a cutout, assuming that it's an NA motor, the gain that you're going to get, unless you have a very, very restrictive exhaust, the gain that you get from that is not going to be great. So like on our test, going from long tube headers with a 3-inch collector extension to those same headers with a 2.5-inch full exhaust with mufflers and tailpipes and everything, I think was only 10 or 12 horsepower. So the change in airfield from 10 or 12 horsepower really is not going to be very much. In fact, you could leave it the way that it is and it will run just fine. How much time should I pull for 35 PSI on E85? 1.8 liter, 8.6 compression. I'm running 15. What motor is this? You got to give me some more information. Yeah, Aaron, I saw that. I don't know why. I don't understand why Aaron's comment is, yeah, that's the problem when you get a bunch of boomers in a group that are stuck in the 80s and 90s mindset, thinking that cast cranks and pistons are going to snap at 400 horsepower. And that's very, very common. I mean, I have to admit, back in the day, every build that we did had forged rods and forged pistons and a forged crank. Because, you know, it's going to break otherwise. Until you start actually doing a bunch of testing, and you're like, look, this is 1,500 horsepower. This is a cast crank. These are powdered metal rods and cast pistons. This stuff is not going to break if everything is right. So I don't worry about that. And actually now the crankshaft is, of all of those parts, maybe the block would be a little bit, you know, would be the last thing on the list, but the crank certainly would be right next to the crankshaft would be right next to the block. The rods and the pistons are the thing that are going to break if you make too much horsepower. And actually at 400 horsepower or 500 horsepower, none of them are going to break. The only time you're going to break those is if you detonated, if you have the wrong timing in or you don't have enough fuel in it, then you could break stuff. But that's not going to be the fault of a cast piston or a rod or a crankshaft. That's going to be your fault because you didn't tune it properly. I have a D15B VTEC JDM variant of the D16 Z6 Civic Si. In my early days as a car enthusiast, was one of the fun little cars. I also had a D16 because I had a 95 SI hatch too, which I loved. It was a good car. We put a Jackson Racing supercharger and all kinds of stuff on it. It was a fun deal. We tried to get the thing to make 200 at the tire, and it was a little bit of a struggle. Had a DX. My wife had one of those too. She has a ticket map that's faster than any ticket I've ever gotten, I think. Richard, did you get the bearer on the dyno? No, I haven't. I haven't even got it assembled. There's a video watch with a stock bottom end turbo big block Ols making 700. I would think that would be possible. Racer D, Aaron's actually not saying that those cranks break. He's saying that he is in a group of people that when he made a comment, all of these people said, hey, you can't do that because these cranks break. And Aaron said, no, they won't break. So he's on your side, Racer D. The Engagement Message is an episode on cutouts. I think they found power, but Hot Rod Garage put cutouts on their Grand National, and the car did not like it. Might have had the tune for it. A turbo motor should definitely like more exhaust flow. So something else was going on there. I got a buddy I'm trying to convert to LS. He's a Gen 1 small block and a Gen 2 LT1. He believes everything should be forged. Yeah, that's not necessary. Have they not seen Big Bang stuff? I mean, it's been out for more than a decade. Steel strut cast pistons in a 450 horse small block and a ski boat, yay or nay? Is that necessary? Just my timing on a 305 El Camino today. We'll break the tires loose from a stop. Nice. See, that's a win. It's pretty cool putting down what you and the engine masters have shown me. Good. I'm glad you're using it, man. And when you get rewarded like that, unlike what I was rewarded with that intake manifold design, when you make a change like that and the motor feels better, that's great. As long as it doesn't feel better and then break. Because a lot of times they make best power right before they let go. I've had that happen before too. Can you use a truck Norris cam with a stock computer? Yes, but you have to tune it. If a hatch has a D in it, yeah, if you have a hatch that has a D series in it already, you can turbocharge that, and it's fun. Well, I have some videos up on. We did some CX Racing cheap. As a matter of fact, the cars belong to CX Racing, and so we did some of their cheap turbo kits for them, and they work really well. I mean, a turbo hatch, like a turbo D series, is really fun. I mean, a turbo B series is funner, but a turbo D series is still fun because now they have torque. I remember the first one I rode in with Kip Kington way back in the turbo days. It was a CRX and it had a turbo. I think it was a D series in it. And it was making, I don't want, like, I want to say 200 at the tire or something back then. And we rode in it. And I remember him getting on and I'm like, man, because I had a 5-liter Mustang at the time. I'm like, I think that this thing would beat my Mustang. I said, this thing is fun. This is really cool. Because I hadn't been in a turbo Honda before that, and it was a pretty cool deal. All the probe force pistons I used were dead sexy. Yeah, I used a lot of those back in the day. Silverlight non-hybrid pistons will. I had to put a bag on my head and put them in the bars. But it still works, though. Richard, if you're giving timing recommendations, curious as what you'd suggest for an old small block Chevy with 10-1 on E85. It's at 20 PSI and air to water cool. Right now, it's only at 19 degrees. Does it have a good cam in it? I think on E85, I wouldn't be scared to go more than that. But if it's working, keep running it like that. If I remember correctly, D17s aren't exactly less work to swap than the K series. Might be mistaken. I don't think I don't think I would go to a D17 from a D16. I hatch at a D15. Can get Ds for basically $100. Any upgrades better than none. Like I said, K swap is not cheap, and a turbo D is fun. Can you still get D series for $100? He's seen your Big Bang stuff and doesn't believe it. Too bad the turbo TBS got a jalapeno sauce tune and blew up. 8.2 pistons and the rings are gapped by me. Well, you can't make people believe the thing that, as we've seen out in the world, you can't make people believe something that they don't want to believe. So no amount of data is going to persuade somebody that wants to go down a particular path. And we can't help that. I can't like hound the guy. Hey, you need to believe this. It's not important. I think we were doing stuff that was over 300 at the tire on the D series with a stock bottom end and ring gap, and they probably put head studs and a gasket on it. And then I think we even tried a camshaft from the guys at Crower maybe back in the day, and then just ran some sort of T3 T04 kind of hybrid deal, and then intercooler and ran the boost up. Well, running full E85 damage a B series internally. E85 won't damage the motor. Detonating the motor will damage the motor, but your E85 is going to make that much better. If it's a turbo B series, it's going to love that. If it's not a turbo, I wouldn't run E85 in it. Will I regret putting a 327 in my Camino instead of it have the 489 I have? You're going to feel the difference in power. That's for sure. I remember the guys back in the day telling me about VTEC stuff. And then back in the day when we were going through this, a lot of the guys were not running VTEC motors. Oh, you can't run VTEC with it. The VTEC that they don't like, turbos don't like those cams. I'm like, oh, I'm pretty sure they do. Does it make more power? Yeah, it does. Well, I said, well, there you go. No, when there's too much overlap and it's just going to blow out and blah, blah, blah. I'm like, dude, I am no expert. Later on, I will be. I'll have my own YouTube channel and I'll be an expert. but then, and even now, not so much. But I'm pretty sure that if you put a turbocharger on a stock B16 and it's tuned right, it's going to work pretty well. Mr. 18 DE Nissan centric compound turbo making 400 wheel horsepower, stock rotating assembly, sealed water jacket, water methyl injection, 35 psi, 6,000 stock compression, stock cam. Sounds like it needs a camshaft in it. That seems like a lot of boost for, well, if it's making 500 flywheel, no, that's probably right. I believe you can break a hammer. Yep. Can you still get $100 for a D series? Every D series in the world is worth more than $100 to me. $8.1. Do you think an S430 C15 cat turbo? I'm not familiar with that turbo at all. Just turbo the motor that you have already. Boost will cure a lot of displacement things. I got a 5.3 block for $20. People around here from time to time throw stuff away. Racer, if you think people don't understand crankshaft overlap, why don't you explain it to them? We're not here to hide secrets. We're actually here to help inform people. So if you got something cool you want to talk about, step up, man. Many circle track classes have claimer rules. We made a claimer special engine with cast crank, ARP rod bolts, and recon rods, silver light pistons. They always had thousands of laps on them, no fails. Yeah. Put a 50 shot on your D15. I have run those a lot. We've run lots of nitrous on them. And B series stuff. I have one. You've never dined on an 8-month-old German Shepherd puppy? Dude, you need to step up and show me a picture. Puppies are awesome. I like German Shepherds too. What will improve the plenum on a hurricane intake, or is it useless? What is a hurricane intake? You got to give me more information. About to put 75 shot on my D15B7, my EF hatch, before I swap it. It will work good as long as the tune's right on the nitrous. It works good. So, we don't even have a poll. Why didn't somebody remind me what's up with the poll, yo? Drum roll. So what did I have that was good? Okay, let's see. Got one. Got you. Okay, who knows anything about valves, intake valves, exhaust valves? Are you ready? Does an undercut valve stem, I call them undercut valves, but we could put stem in there. Valve stem, you know, where the stem kind of necks down right before the valve face or the back of the valve face. Does an undercut valve stem improve the flow rate of the cylinder head? We see an improvement by putting those kinds of valves in there. You know, swirl polished undercut stems. Boom. Trick stuff, racing stuff, race stuff. LS2 GTO M6 can use a truck nurse cam. Yes. In fact, you could even go with something bigger than that. But any camshaft you put in with a stock computer, you're going to have to tune it for. No bolt, no pizza. .4.8, 2400 or 2004 Silverado. Can I use truck Norris cam using stock computer? Yes, that you have to have a tune though. Every camshaft. I know that people have said, "Oh, this cam doesn't need a tune." I'm like, well, then you're not getting everything that camshaft has, or the camshaft is really not offering very much of a power gain. VTEC versus no VTEC on a turbo Honda. Definitely VTEC. It's amazing how happy the turbo gets when VTEC kicks in. Valves. What really helps flow is a back cut on the valves. Or what I like doing is I drill holes in them. Absolutely improves airflow. So I'm guessing you voted yes, right? I forgot the no idea option. So this is from Racer D. He's telling us what crank overlap is. Crank overlap is the amount of metal between the main bearing diameter and the rod bearing. This is the only solid metal going through the entire crank from the front to the rear. Very cool. So is that going to help determine the overall strength and the frequency of the crank? Undercut stems may improve flow on intakes, but seldom on exhaust. Yes, because it's going the other way. I did have an interesting comment from somebody, and they were telling me about, we keep going back to this because it's cool stuff. When we were talking about the spark plug test where we tested the plug gap, so giant plug gap, and we were talking about under boost. So when you're under boost and the boost, blowing the spark gap out or whatever, some guys took it as it blowing the piston out of or blowing the spark plug out of the cylinder head. That's not what we're talking about. We're not talking about the modular motor stuff that everybody talks about. What we're talking about is, does the air and fuel rushing in as the sparks try to jump, and we talked about this morning in the live feed, does the air rushing in just blow that out, like you blow out a candle? And I was telling them that's what it makes it sound like. That's why I don't like the blows out the spark. That's why I don't like that, because that's not accurate. And I got one guy, no, you should see it. We did this on this test. I'm like, dude, I'm sure that you made a spark and then blew it out with some other kind of thing, but it's not happening. The spark is not happening when the air is rushing in. The air has rushed in, and the valve has already closed, and the piston's coming up to compress stuff, and that's when it tries to spark. There's no more air rushing in. That's not happening. Oh, yeah, it is. I said, you don't understand what's happening in a motor then. You don't understand the internal compression or internal combustion engine. That's not happening. There's no more boost coming in. There's no more fuel coming in. None of that's happening. It may be swirling around in there and creating havoc, but it's not rushing in anymore because both of the valves are closed. Because if both of the valves weren't closed, when it was coming up, it'd just be blowing that stuff back out. And then it would be irrelevant whether you had a spark or not, unless you just wanted to throw flames out, because that's not how it works. But again, just like with the other person that we were talking about, you cannot, if the guy's going to dig his heels in, you can't convince him with any sort of data or logic, because he's going down this path already, and you just got to let him go down the path and then find out he's going to all of a sudden have a good idea one day. He's going to start understanding what's going on with the dynamics of internal combustion engine. He's going to go, oh yeah, look, here, I figured this out. That guy 10 years ago told me this, but I figured it out. Thanks for asking my question on E85. I read the limit on compression with pump gas 91 octane is 11.5 to 12. Compression doesn't sound right. No, that you need to stop thinking about compression versus octane, because compression, static compression particularly, is not the only thing that determines how much or the octane that you have is not the only thing that determines how much static compression you can have, because there's lots of other things. You can have 12 to 1 static, but if you put a 300 degree at 50 camshaft in it, there's no dynamic compression. You probably will never detonate the motor. So you can run even higher compression. So the camshaft will have a big effect on that. You can soften the chamber. Maybe you can get away with another half a point or full point. Do you have really cold air or do you have really hot air? If you have really hot air going in because you are drawing air from near the header, let's say, you can't run either one of those compressions. You can only run 8 to 1 or 9 to 1 because your air temperature is so hot and it's going to detonate anyway. So there's a lot of things that go into that. It's not just this direct correlation that people want. People want these like black and white absolute things, and just that's not the way that the world is. Isn't blowing the spark a thing that increased density requiring more spark energy across the bridge? Well, that's what I'm talking about. When I was explaining this to him, I was telling him that what's happening is that there's so much pressure that there's insufficient voltage for the spark to make the jump. It won't do it. It's not starting and then getting pushed away like blowing the spark out sounds like I said, like blowing out a candle. That's not happening. What's happening is that there's so much pressure that it can't do it. It can't physically make that jump. Yeah, Dan, I know. I didn't know that there was any airflow during the bang stroke of the engine. I tried to explain that to him, but he wasn't having any of it. When tuning air fuel for supercharger combination, do you just shoot for a richer air fuel, or do you same as NA? Does it matter? It matters a whole lot. You want it to be richer, just like with any kind of boost. You want it to be on a supercharged motor. I would say in the 11s is going to be safe. Mid to 11s are going to be safer than high 11s, just to be safe. Exhaust works better with the full tulip and no back cut. Nice. Tuning area far too large plug gap raises the resistance to the ionization of the airflow mixture, which must take place to create plasma that spark moves across. The door is closed. Spark plug can't jump to the ground. High cylinder pressure. That's why it closed the gap. Found a burnt valve flows very well. That's what I was talking about. That's why I want to drill holes in it so that you can get, you can channel that. And then when I drill the holes, I drilled them at an angle so that I induce swirl. Pretty cool. 30 thousandths or so gap, and the power that we are using on plugs ain't nothing blowing that spark out. Yeah, 30 thousandths is not what I would use for boost. 30 thousandths NA would be what I'd use, but under boost we would run it more like 18 or 19. Ran 13 to 1 on 91s. Engine built for nitrous that closed the intake valve late. Every engine is different and special. Yeah, they're all different and special. Just like how women claim to be. Dan, just bitter. I run 11 to 1 on 94 with 16 pounds of boost. See, it makes every pass super exciting. Are you holding your breath the whole time when it comes into boost? Still ain't no boost blowing out either one. No, it's not going to. That's not really a thing. So, Karlov, at 16 pounds of boost on 94 octane at the torque peak, do you have single digit timing there? Dave, I started flow testing in 1972, and I've seen very few heads that cared about undercut valve stems. The gains are so small, it means very little. That's kind of what I thought, and that's what I told the guy. I said, honestly, I think when you're looking there, you're looking in the little area. You're not looking where lots of stuff happens. But he was convinced that undercut stems and arcographite were the way to go. K24, 15 degrees. Okay. What turbo are you using on their car? On a K24A2? A huge turbo? Or are you saying like you have a 98 millimeter? Oh, a 76. That's pretty big. Maybe that's important for a class rule or when you're trying to get every little bit out of the motor. It might be. My point was that, and the discussion that I had was using an undercut stem in a head. The first thing that I would want to look at is what is your combination. So are you the guy that has gotten every last CFM possible and are making power out of every one of those CFM offered by that head, and then putting an undercut stem gives you 1 or 2 or 5 or whatever CFM, whatever it is, and so that will actually help you. If you have a 300 CFM head and your motor's making 500 horsepower, an undercut stem is nothing. It's not going to do anything. It's only when you're trying to get the last little bit out of it. And I was trying to explain that to him, and I think he kind of got it. Now I want to go grab a bunch of D-series units, different sizes, inspect them just for fun. Just take a D-series VTEC motor, put ring gap in it, put head studs on it, an MLS gasket, and put boost on it. Just for fun. So Dan, you think that'll just jump the gap over to the cylinder wall? Let's forget it's possible for Richie to remember everybody's builds, even if you have a K-swap Oldsmobile cutlass and a DIY intake manifold. I just didn't know what timing you were running. If you're going to build a supercharger with a turn off to go back to NA, where do you tune between and make it work? The tune part of that's very easy because you'll have in your tune, you'll have an NA tune. An NA tune will be part of your boost tune because you'll have a 2-bar map sensor, let's say, and the NA part of it will all be tuned. So when you're running NA, it will all be tuned. And then the boost part of it will be tuned in the boost part of it. I wonder how many remember Arco Graphite. Probably not many. On my Quad 4, I reshaped the intake valves myself and found big gains with a nail head valve. That head flowed 306 CFM at 450 lift. That's a lot. Don't forget the block guard. Gateway, did you write it down? If I can get somebody to write something down, then I know that the live feed is a success. Let's see what our poll is doing. Uh-oh. Man, I just go to polls and the polls come in. Let's see. Hide user on this channel, and you are out. Just like that. I wish there's a cheaper options to adapt K to rear-wheel drive. What did you run in your Civic? 254. I wish. No, we ran 227. I have a 385 small block AFR 195 hydraulic roller, switching from a stealth dual plane to an open plenum professional products. How can I improve the plenum? So why do you want to improve the plenum? I don't know what you mean by improve. Do you want it to flow better? Do you want it to, lots of guys go in and port those and make them better. I don't remember what the inside of that particular one looks like. You're going to see a change in low speed power when you go from a dual plane like you had. Your stealth was a dual plane, right? Yeah. To a single plane intake manifold. And you're definitely going to see a change in power. It's going to be softer down low. I'm hoping that you gain power up top. It sounds like hopefully you have enough camshaft and stuff in that 385. So, Mike, why are you banished? What did you get banished from? So our poll is 75% saying yes, that an undercut stem does improve the flow rate. Best way to rate spark energy is in joules of energy or watts or amps, current secondary side, then in crankshaft degrees of rotation. Why is nobody hitting the like button? Casey, I know. I don't know what the deal is. It's like this is my first time here. So for high pressure LS oil pumps, what numbers are too high? 1,000 would be too much. I would go less than that if you can. The oil pressure should not be too high ever. If it is, you have bearing clearances that are wrong, or you have too much pump, or you have the wrong viscosity oil. It's going to be higher when it's cold, and then it's going to stabilize, and it's going to rise with RPM, which is typically what LS stuff does on a gerotor pump. I'm thinking of selling my K to BRZ adapter kit and going with ZF8 HP70 for those lower first and second gears and fast shifts. Good evening, Richard. You never stopped working. I thought that I was going to be able to finish my other video. I've tested it. I'm doing LS, just so you know, and we're doing Elgin cams, and we're doing 2 smaller Elgin cams versus the sloppy stage 2. And because I know you guys are going to ask, I'm going to throw in the Truck Norris thing, probably just as a comparison for big cam, small cam kind of thing, because you guys will look at that, and now people are going to say, "Well, Richard, but what about the red hot cam? Why don't you throw the red hot cam in there too?" So I could put all that in there, and that way, you know. No matter what I put in there, somebody's going to say, well, why didn't you put this other one in there? But yes, Engine Masters did recently test a bunch of oil pumps. They were looking at it for power, I think. Comparing the Gen 5 6.2 heads to the 6.2 Gen 4 heads, do you think the Gen 5 heads having higher exhaust flow is something that is compensated by greater exhaust duration split in Gen 4 cams? I myself would rather have the I'd rather have more head flow. I'd rather have more exhaust head flow than I would staggering the cams. I'm going to stagger the cams anyway, because doing that is going to help on any cylinder head, regardless of what the intake to exhaust flow relationship is. When you change that camshaft, whenever I've tested it, the cam still does the same thing. Guys are going to argue with me about that, but there'll be guys that haven't actually tested that. So I would rather have head flow. I'd rather have more head flow, because with more head flow, you can make more power with less camshaft. Motor Trend on Demand just did a good video on explaining oil pumps. Sorry, I just got here. Are we talking about what we got done this weekend? Yes, you're always welcome to do that. My 5.3 with high flow, high pressure oil pump makes 40 at idle and peaks in 80 when the RPM picks up. Is it at 80 up at like 6,000 or 6,500? Because that's fine. When MSD first came out with their magneto, there were lots of problems with grounding correctly. I had an engine on the dyno that micro welded the piston ring to the piston jumper between the heads fixed. How did it weld a steel piston ring to an aluminum piston? I'm curious about that. Mike, that makes sense. You think that there's a quicker diminishing returns on a Gen 5 head with exhaust duration compared to Gen 4? I don't know. I don't know. You'd have to test lots and lots of camshafts on those to see what the difference is. And the other thing that you're looking at is I would not just look at intake and exhaust flow, because there are other things going on with those heads. There's difference in port size or different in chamber. There's lots of other things going on with those heads. How much horsepower is a windscreen worth? Are you talking about a windage tray? Windage trays can be worth a lot of power, especially on a big block, and they're highly recommended on a big block. So when are we going to see Richard Holder on Motor Trend? Motor Trend on Demand season 1? I don't. How many seasons do they have? They have a bunch of them, right? Should have all these dynographs on a website compared. I don't have a website. I know the MSD 44 amp magnetos are badass. 60,000 volts over 1 amp. Ew. That's pretty zingy. 800 millijoules output. Because you're trading the exhaust flow for a smaller intake valve. So there's a lot going on there. Direct injection, piston design, all of that stuff. I do know that it seems to be that the LT motors with similar kinds of mods are making more power than the LSs. And I know that that's going to... Oh, the ring to the block, maybe. Yeah, not to the piston. Is that probably... That makes more sense if it is. Oh, so the question is, when am I going to get my own show? I don't know. I'm not part of Motor Trend, so I'm not in that family. I'm definitely a redheaded stepchild. Did a 6.0 Corvette LQ4 using a high volume pump. First fire Friday lasted 30 seconds before something went wrong with the fuel regulation and it died. But I saw 132 PSI. Yeah, that seems like a lot. Make sure that the pump is not, that the bypass is not stuck. And that, or that, not the bypass, that the plunger is not stuck in it. What happened to the 862 versus 243 video that you did with Brian Tooley that you said were coming? I need to do that. I don't have all the data for it, but I could try to get it from them. Actually, what I want to do is I want to revisit that with, I think both the head that we had, the 243 head that we had was like the best flowing head by 20 CFM that I've ever seen. So I don't know what's going on with that. And the 862 heads that we had were the worst flowing and worst performing heads I'd ever seen. So something's going on there. And maybe, and I talked to Brian about this, and it may be that the ones that I had, the reverse was happening. So I think more testing is necessary, but I still would never change. If I had a 4.8 or a 5.3, I would still never upgrade the heads from a 706 or an 862. So I saw some guy post a video about how he puts LT heads on LSs. I don't understand why, but it's interesting and they're different. Brian Tooley did that. They have an LS with LT heads on it already, and they're running it around. The problem is it takes so much to do. It takes a different camshaft. It takes, you have to run all the LT stuff. You have to run LT headers. You have to run an LT intake. You have to run a custom camshaft. So it's a lot of work to do. And the thing is, there are really good heads already available for LSs that don't require all that. You have all the other stuff that you have already. You have your headers, you have your intake manifold and stuff. And so a head upgrade for that, if it was a situation where you could do that because there were no other options for you, that might be something. Because we talked about that long ago about doing 5.3. We got all excited. We're like, yeah, we should put the 5.3 L83 heads on a 5.3 or a 4.8 because they're so much better. And then we're like, yeah, but it's going to take a different camshaft and it's going to take a different intake manifold. It's going to take different headers. It's going to be a different motor by the time you do that. So it's not a good deal anymore. Even if you get a power gain from those heads, it's just not really. Have you tried Total Seal gapless rings? I have. I ran them on my Engine Masters motor, and I don't use them for boost. There's no reason to do that. I haven't compared them to some other kind of ring because that's a fairly involved test because you got to break in both sets of rings. Use the windage screen instead of the tray on a pan with a kick out and a crank scraper. Don't forget the crank scraper. Gapless rings don't make more power. Blow by goes down, but for some reason it doesn't translate into power. They've tested that on a lot of their super racing motors. Tim, I'm going to try to fix in my first. I'm going to try and fix my first cracked cast iron 318 block. Can you just go get another one? Window tray is good for big blocks for sustained RPM. Actually, just for running on the dyno, we usually have oiling issues with big blocks. If you, depending on the pan that we use, you need to have a really good oiling system on a big block, and even more so if they're stroker versions. We play with oil level a lot with big blocks because we get into windage issues, and it's worth power, and it also helps the oil pressure curve, which will help the life of the motor. How do 2-inch intake valves do on a 706 or a 862? Somebody sent us a set that I think, or they said just had that done, and they did flow more. But you have to, and I think but I think he did unshroud the valve. But we would do that anyway, even on a 706 head, because even when you unshroud a stock intake valve and an exhaust valve on an 862 or a 706 head, it picks up flow. So on a 2-inch, it also does that. But the 2-inch valves seem to help. And when you do like when I got the ported versions of the 706 heads way back from Brian when he owned Total Engine Airflow, and now even Total Engine Airflow now, when they do like a stage 2 ported head, it has a bigger intake valve in it. So we'll take a look while Karlov is promoting himself. Does an undercut valve stem improve the flow rate of the cylinder head? 75% are saying yes, 25% are saying no. So we'll close that poll out. Will you ever design your own camshafts? I may have already done that. But I'm not going to sell them. What you might see in the near future is some signature series stuff, maybe. But I don't want to be shipping them and selling them and stuff. What cam is on my shelf? This one over here. That I think is a solid roller LS cam. Some sort of big solid roller thing. It definitely is the wrong cam because I will never use it in anything. Never on anything. And then I have another one. I have this one here. This is also the wrong cam. Let's see if I can show you why this one's the wrong cam. Where's my lobe at? Oh, here it is. See, I have it zip tied. Oh, that's got some chips out of it. Oh, here we go. This is a bit lobe right here. I don't know if you can see that. Can you see this one right here? Let's see. It's like super ugly. So that was a bad one. What camshaft was this? That is a comp. I don't know what it is. 097838-17, 326, 311, 34. So it's definitely an LS cam. It's got a bad lobe. And I don't think it was a cam design problem or a metallurgy thing or anything. I think it was in one of the motors that went bad. One of the lifters went bad. Richard, I read that BTR did some tensile testing of GM valves, of like the valves in the LS heads or something. I don't know about that. I have to ask Brian. So what liter engine NA would be the limit of a 706 head? I don't know that it would be displacement limited. I think it would be power limited because that head flows about 230 or 40 CFM, if I remember right, on a 706 head. But a ported version flows over 300, so that will support 600 horsepower. Yeah, this would be a good home defense piece. You don't want to get bonked for the cam. That's not good. Can an intercooler be too big? Maybe if you had one that was 6 or 8 feet across or something. If it was an air to water or an air to air. Do you have any 5.7 Hemi castings laying around? I might. Yeah, the camshafts, that's like super heavy. And it's also, to add, it's got lumps on it and they're sharp. So it's got all kinds of bad things going on. Yeah, ask him. They tested the exhaust valve from the LY6, I believe. It was curious how strong the LS3 intake valve is since it's so light. Yeah, is that a hollow stem valve on the LS3? I know that the some of the stock valves are much lighter, and so you can run more RPM with those and different spring rates. The first Duntop cam for the 283 was referred to as the 097. Hollow stem stainless, a weight of 87 grams. I remember Brian telling me about that because I remember when we replaced those. I thought that the LY6 that had an 823 head or an 821 head. I can't remember now, but it doesn't have the good valves in it. It's just got heavy valves on it. But still, we ran pretty good RPM on those. I've been welding up cracked intercoolers on the Bart diesel engines. They're huge, 3 feet by 3 feet with 4.5 inch inlet and outlet. What size turbos those things have on them? There's a show V8 for sale for $500. I've driven those at the track. I like those. I drove that when I was instructing one time. That was at Laguna Seca, because I remember going around. We were talking about doing the Zanardi pass up on the corkscrew. I think I can do dueling camshafts because I got 2 of them, right? You got to be a blacksmith though to wield those things like that. That's pretty beefy. Ever tested a Mopar 413? They have at West Tech, but I never have. The corkscrew is awesome, but it's not nearly it's the most famous turn, obviously, but it's not nearly the scariest though. I have a 2010 5.3 with flat tops. So that's like the L33 that I have. Don't know what heads it has, but I have a pair of 862 and 706 heads. Have you tested that compression combo? No, you're not going to change it by very much, because the difference between, they would have put 799 or 243 heads on a flat top 5.3. That's what they all came with. So that's what head would have been on there from the factory. If you put the difference in CCs between a 706 head and a 799 head is not very much. It's only 2 or 3 CCs. You're not going to really change it that much. I'd like to know how many horsepower can a 355 with a 200 cc Maxwell head with the intake manifold 750 Summit Racing carburetor, Eagle crankshaft, comp cam. I need to know what the duration at 50 is. And does the head flow 200 CFM? Is that what you're talking about? If it's 200, if it's only a 200 CFM head, it's not going to it's going to be like a 400 horsepower motor. If it flows more than that, or if it's 200 cc's and it flows a lot more than 200 CFM, which I would expect it would if it's any kind of aftermarket head, then it can support more. Did you see at the Historics, they raced hill climbs up the corkscrew the other way? That would be cool. I remember they used to have drivers race up that. They used to run up the hill. You want a young driver for that. Gran Turismo 3, if you hit the rumble strip at the top of the corkscrew going fast enough, you could jump the whole corkscrew. That'd make the braking zone on the downhill side pretty iffy, but Zanardi passed there. He passed through the dirt, which was awesome. A 200cc head, 2.2 valve in a is it a 202 valve or 2.2 valve? So for a small block Chevy, a 2.2 would be really, really big. Add a centrifugal supercharger on top of a TPI. We've run that many times, and I don't have any videos up on it, but we've done a lot of that back in the Vortec days, and it doesn't make the TPI want to rev, if that's what you're trying to do. It still wants to make peak power in that RPM range. It will keep it going a little bit more like it does on a 5-liter Mustang with the stock, because a 5-liter Mustang is essentially a tune port Ford version because it's a super long intake manifold. So it's the same kind of deal. They were doing the same thing back then with lots and lots of runner length. And it will help it rev a little bit, but not a lot. Buy a Fiesta and build a Shogun. That would be cool. I do like those. I'm liking it. I'm liking it. 2 minutes left. Official warning. 1990 Ford F-250 with the 302, the one with the cast distributor gear, not steel. Yeah, because that's going to be if it's a 302 and a 90, that's going to be a flat tappet cam, not a hydraulic roller, right? A Fiesta or a Festiva. Both of those are good, by the way. I think, is it Matt from Sloppy? Doesn't he have one of those? I thought I saw him doing chassis dynos with one of those. It was like 55 horsepower or something, which again is cool. An F-250 is not a 3/4 ton, right? Is it? Or oh yeah, it is. The F-150 is a half ton, and then the 350 is a 1 ton. Is that what it is? Leno has a Shogun. Yeah, that was actually over at the show shop back in the day. I remember. So too big for a 355 small Chevy, 200cc head, 2.2 valves. I don't even know how 2.2 valves would even fit in that head. I've never seen small block Chevy heads that have valves that are that big. Normally 202 and a 202 and a 1.6 are very, very common on all of the aftermarket small block Chevy heads. 194 and 1.5 are also a good valve combination on small block Chevy heads. My dad has an 87 250 with a 302. We need more 2JZ. Nope, that's pretty low on the list. A 1JZ would be higher on the list than a 2JZ. The difference between a IS 300 and a Super Turbo. Although I did see, and then I got to get going. I did see a really, really clean. I stopped, and my wife was like, "What? Why are you still standing here?" I'm like, "Because that's an OG like Super Turbo." I said, "Do you realize how?" She's like, "It's not my kind of car." I'm like, that's a Super Turbo. That's really, really cool. You don't see those driving around. I said, you know how much money that car's worth? It's probably worth $8 or $10 or something. But it was cool. It was really clean. It was not overdone. It was very, very nice. And this was down in Southern California that I saw it. Shut up, Katie. Shut up. Shut up. How's it for you too? The 2010 5.3 has flat tops with valve reliefs. I didn't think that any of the factory ones had valve reliefs. Was it a variable cam time motor then? Was it a VVT motor or something? Usually that's why they put the valve release in it. It is worth tens of dollars. Before I do any of the 1J or 2J or 1.5 or 2.7 or whatever they are, I would do the RB25 because I need to get that running. And the L28, L28 would come way before the Toyota stuff. Victor, yours is the last question for tonight. I've got a 2500 Silverado HD, has the LQ4. Must be an early one. 317 heads, have the truck Norse cam already. Will I benefit from AFR Enforcer 210 heads? Yes. Those heads flow more than a 317 head, but you also benefit. I'm hoping that they have a smaller chamber. I don't know what chamber volume that those heads are available with, but get something that's in the 60s and not in the 70s. And on that note, it's time to go. I've got got videos to do, or a video to do. And I got another one tomorrow to do, and then 2 more live feeds. And that's my life. It's just super awesome. Thank you guys all for showing up. I will see you all tomorrow. And we're ending, and we're ending, and we're ending.